Right. Okay. Hi, everyone, and welcome to ISTQB training, CTFL, session number 17. In last session, we went through, we still went through the module 5, test management, and in that we covered test planning and estimation, and also test monitoring and control. So module test management is not finished yet. Today, we will complete the rest of the topics in that, which will include configuration management, risk, and defect management. Okay, so let's start with configuration management. So what is configuration management? So configuration management is the process of managing products, facilities, and processes by managing the information about them, including changes, and ensuring that what they are supposed to do in every case. Okay, so I have just tried to explain this in an example. So when we think about a project is consists of many things. There are softwares, hardware, tests, various kind of documentation, release management, and much more. And all that makes up a project. So the configuration management is basically a process which manage everything which is part of that project or product. For the concern of this syllabus, ISTQB Foundation syllabus, we will not go in much detail of configuration management itself, but we will be talking more about in terms of testing. So for testing, configuration management will involve controlling both the version control, like what version of code to be tested, and also the documents which are used during the development process, for example, requirements, design, and plans. So in this exam, wherever you will see the term configuration management, it will be with the context of testing. Okay, so during test planning, configuration management procedures are infrastructure. There can be different kind of tools which should be identified and implemented. So configuration management is basically part of test planning, because that's where because you are aware of the project, you know that what kind of testing you are doing. And so when you are planning, so configuration management need to be part of that. Okay, so we just said that if we talk about testing and configuration management, then it involves the version control and also the documents which are used during testing. And in both cases, configuration management should make sure that the traceability throughout the test process is the way it should be. So a good configuration management system will ensure that the testers can identify exactly what code they are testing, what version of code they are testing. And as well, they should be also having the control over all the test documentation, for example, test plan, test cases, defect logs, etc. Okay. So to properly support testing, configuration management ensures the following. All test items are uniquely identified, version controlled, tracked for changes, and related to each other. So whatever you are testing, it can be a requirement, it can be product itself, the component, whatever you are testing, we need to make sure that all these, the configuration management is taking care of all these things, version controls, what kind of changes were there, and how they are linked to each other, because we don't want to end up testing something which is not the right version. Like how about that if you are, if you have planned 10 days for testing, and then once you have spent 5 days, and then you get to know, oh no, you were testing the wrong version. So this is all what configuration management takes care of. It can be done manually as well, which is very, very difficult nowadays. So there are lots of configuration management tools which actually takes care of that. Okay, so the second one is all items of testware are uniquely identified, version controlled, tracked for changes, related to each other and related to versions of the test item so that traceability can be maintained throughout the test process. So that's what we already mentioned earlier. So over here, testware is nothing but all kind of test documentation. So any kind of test documentation, for example, test plans, test cases, test reports. So these are all referred as testware. So they should be also uniquely identified. We should be able to uniquely identify them just like as our test objects. And then the third one is all identified documents and software items are referenced unambiguously in test documentation. So wherever in the test documentation, like for example, in test plan or test cases, wherever we are referring to any kind of software or any kind of other documentation, they should be having specific references. In terms of references means like which version. So we need to be that specific so that we know that what are we talking about and what will be tested against which version, and all this needs to be managed in configuration management. So in terms of ISTQB CTFL configuration management, that's all what you need to understand and remember. If there is any question on that, do let me know. Next is risk and testing. So we have been talking about risk a lot from, I think, first, if not the first, then maybe from the second session. We have been talking about risk at each and every point and how important it is in testing. And I would say that anyone who's already testing right now or who will be testing in future, you will see that now risk mitigation, risk-based approach, these are the things which you will be using a lot in your day-to-day life as a tester. So it's really important that you understand this concept well, and I will try my best to go into as much detail as required. So first of all, what is a risk? Risk involves the possibility of an event in the future which has negative consequences. So that's why, so this is something which has not occurred yet, but there is a possibility that something wrong can happen. So that's why risk needs to be planned as part of the testing process. We need to plan for these consequences beforehand so that we can either eliminate these risks or we can reduce the impact. So now as we are clear with what is a risk, now there are different levels of risk because of course if we are saying that there is a risk, the next question would be that how bad it is. So of course there should be something in order to measure that level of risk. And how we measure the level of risk is, this is a simple formula which you should remember: likelihood of the event and the impact from that event. So likelihood of the event is also known as probability. So if you see probability somewhere, it's the same as likelihood of the event. So if there is an event which may happen in future, then how we calculate the level of risk is that what's the likelihood of that event to occur, multiply by how bad the impact would be of that event. And then together, the product of these two dimensions, these are two dimensions. So the product of these two dimensions of risk help us to calculate the level of risk. Okay, so this is an easy way to understand, and this is usually what happens when we have to measure the risk of any let's say unwanted event. So we have impact on x-axis and probability on y-axis, and we can measure it from, let's say, 0 to 1 as well. We can do it in percentages as well. It depends that what kind of scale we are using. But let's say if there is a risk, and if we evaluate that risk and it has a low impact, and low probability, then it will fall here. A high impact and high probability will fall here, and then vice versa. Low impact, high probability, and low impact, high probability. Okay, so now this is a very, very easy way to calculate the risk. And now how it will be interpreted in different organizations is completely up to them. Like for example, over here, of course, anything which is falling in this quadrant, that would be of high risk. Then this and this will be medium and this will be low. So in some organizations, when we say that we have to go for a risk-based approach, we can go like high, this medium, this is also medium, this also low. So we can range them like that, we can order them like that. Or in some organizations, there are also some numbers which are associated with it. Like for example, for high, a number can be given, let's say 10. For medium, it can be 5. For low, can be anything from 0 to 4. So it depends, but this is basically the way all the risks are ordered. Okay, so I hope that is also clear, and we will also do an example later on, which I believe will help you in understanding if there are still any kind of issues. So when we talk about risks, there are two kind of main risks: product and project risk. So first of all, let's see what is the product risk. The possibility that a work product may fail to satisfy the legitimate needs of its users or stakeholders. So sometimes it's very difficult to differentiate between a project and a product risk. And an easy way I would say is that, of course, we will go to the project risk as well in a while, but I would say that if you're not able to differentiate that which is a project risk and which is a product risk, then if there are any uncertain events that can impact the project ability to meet its objectives, like meet its deadline, etc., then it's a project risk. And anything which is resulting from the problems with the delivered product, then it's a product risk. So over here, we are talking about the possibility that a work product may fail to satisfy the legitimate needs of its user stakeholders. Means a product, when it will be delivered, if there are any issues, if it's not able to perform the functions the users are expecting from it, then it will be product risk. And when the product risks are associated with specific quality characteristics, then the product risks are also called quality risk. Okay, so you must be familiar with these quality characteristics because we have covered them quite a few times earlier as well, like functional suitability, reliability, performance efficiency, usability, security, compatibility, maintainability, and portability. So these are all quality characteristics of a product. And these quality characteristics, when they are associated with product risk, then together they are called quality risk. Because of course, if these characteristics, these are the quality characteristics, and if they are affecting the product and there is a risk, then it will be referred as a quality risk. Okay, so now we'll go through a few examples of product risk. So for example, software might not perform its intended functions according to the specification. So you have delivered a software, but it fails to perform the basic functions it was supposed to do. So even if there are no bugs, it will not be a good product because it's not doing what it was intended to do. The second one is software might not perform its intended function according to user, customer, or stakeholder needs. Okay, so in the first one, it was like according to the specification, that whatever the specifications were given, it was not according to that. And at the end, it's not according to how the user wants it to be, how the customer asked you to do that. Maybe in this case, customer asked for something else, and then the specifications were made were misinterpreted, and then based on those misinterpreted specification, the entire software was developed. Then the next is a system architecture may not adequately support some non-functional requirements. So this would be the case where a software is developed perfectly fine according to the specification and as per the needs of user or customer. But when we go live, then we come to know that the architecture may not be able to perform well. Like for example, maybe there was a website and when it goes live, it just crashed because there were a lot of users, there was a lot of traffic on that website, and the architecture was not sufficient enough to cope up with that load. So that's why it mentions some non-functional requirements. So that would be a product risk as well, because though the product was really well, it was developed really nicely, but if the architecture is not there to support that product, then of course that's a risk. A particular computation may be performed incorrectly in some circumstances. Okay, so if there are any kind of computations, like any kind of calculations, and if they are performed incorrectly in specific edge cases, then that can be also part of, that will be part of a product risk as well. Then the next is a loop control structure may be coded incorrectly. All right, so then of course that would be, that can be also a trigger in case of few scenarios. So if there is a loop, a while loop which has been added in the code, and the structure of that loop is not coded properly, which means that might be for few inputs, it might not work, or it might just keep on being in the loop constantly as not per the requirements. So that would be a product risk as well, because that would be an issue in the code which will actually affect the delivered product. Response times may be inadequate for a high performance transaction processing system. So if we are using a transaction system, an online transaction processing system, then of course we are expecting that we get adequate response from that. But if we go to a website and it is very, very slow, and the response times are not as the user is expecting, then that's a product risk as well. And that can be related to the architecture as well, because it might be because there's an issue with something with the architecture. Maybe the server is not able to bear that load, and that's why it's resulting into a slow response. Or it can be something totally not not linked with the server or architecture, but maybe something in the code which needs to be fixed. And the last one is user experience feedback might not meet product expectations. So the user, at the end, of course, the product has to be used by a user. So the user experience, if the user is not getting a very friendly interface, then that would be also acting as a product risk. Okay, so now after product risk, we will be moving on to the project risk. So this involves situations that, should they occur, may have a negative effect on a project's ability to achieve its objectives. So these can be any uncertain events which may happen. So they haven't happened, but they may happen. But if they happen, then there can be a negative effect on the project's ability to achieve its objectives. We will go through the type of project risk, which I believe will make it more clear. Project risk may affect both development activities and test activities. So it doesn't affect only testing, it impacts development activities as well. It impacts the entire project, because let's say that when we are planning for a project, testing is a part of that. And anything which affects the project, it will affect definitely both development and testing activities as well. In some cases, project managers are responsible for handling all project risk, but it is not unusual for test managers to have responsibility for test-related project risk. Okay, so because we're talking about the entire project, and as I mentioned that anything which affects the project, it will have an impact on testing as well. So usually project managers are the one who handle all kind of project risk, and if anyone identify any risk, they report it to the project manager and then they handle it. But also it depends that if there is a project which is more focused only on testing, then usually test managers also do that part for handling the project risk. Okay, so examples of project risk includes project issues, organizational issues, political issues, technical issues, and supplier issues. And now we will go in detail in all of these issues. So first of all, let's go through project issues. So what are project issues? So it can be delay may occur in delivery, task completion, or satisfaction of exit criteria or definition of done. Okay, so if we are working on a project and anything which is affecting its delivery, which means that the tasks are not completed or you're not satisfied about the exit criteria, because exit criteria actually defines that when the the project is good to be signed off and when we can release it to production. So the delay which occur in delivery, that would be a project issue. The second one is inaccurate estimates, relocation of funds to higher priority projects, or general cost cutting across the organization may result in inadequate funding. Okay, so in the beginning, when the test planning is done for a project, if at that time the estimates are not accurate, and at that time, uh, let's say that during the project, we come to know that the estimates which were planned earlier are way different to the actual ones, then of course that will affect the project timeline. The same goes with the budget as well. So if there were some funds which were associated for a specific project, and then in the middle of the project, those funds are being used for a higher priority project. And this is very normal. If there are 5 projects, of course, the company wants all those 5 projects to be done. But in case if there is a situation where they have to make a choice between them, then of course they will go for the high priority one. And if there is any cost cutting across the organization, if there are any issues and the organization, they need to step back and they need to cut their costs, then that will also result in affecting a project. Late changes may result in substantial rework. So late changes, so this is a very good example of when we say that the testing should start as early as possible in a project, because the later, let's say that when we are doing dynamic testing during test execution, if there is a defect reported, which is actually a requirement bug, and that actually requires to change the requirement altogether, then that will be a quite big piece of work, and those kind of changes may result in a lot of substantial rework, and that will affect the timeline of the project. So these are the issues which lies under project issues. Second one is organizational issues. So we spoke about project issues, and then these are the organizational issues. Skills, training, and staff may not be sufficient. So maybe a project is going perfectly fine, but the organization doesn't have any training process for the resources which is required for that project, or specific skills are not there. So that would be an organizational issue, because it's an organizational responsibility to hire the people or train the people required for the projects they are working on. Then personal issues may cause conflict and problems. Okay, now, so they might be trained enough or skilled enough, but maybe they have some personal issues. Like if there are 5 members in the team and 2 members doesn't go well with each other, then of course that will show up, and in the how it, and it will impact the project as well. So the organizational, it will be an organizational issue, because at the end, of course, someone has to step in and resolve those conflicts. Then the third one is users, business staff, or subject matter experts may not be available due to conflicting business priorities. Okay, so any users which we required, let's say for a specific project with the specific domain knowledge, specific expertise, they might not be available for a specific a project, and because they might have some conflicting other priorities in the business. Of course, that would be an organizational issue as well, because if they are required for a project, then it's organization's responsibility to prioritize that. Okay, so the next one is political issues. The first one is testers may not communicate their needs and or the test results adequately. Okay, so it's not very uncommon that the testers and the rest of the team, or maybe tester developers, they have a rift. And sometimes testers might not want to communicate the results or what they need. So that's why communication is the key in the team. And if it's not there, then that will impact the project. The second one is developers and or testers may fail to follow up on information found in testing and reviews, for example, not improving development and testing practices. Okay, so when we are working on any project, then of course, when we are doing different things, when we talk about in terms of development and testing, there are a lot of things where we do the reviews and we point out different things where there are gaps, and there is a tendency to make improvements. But if developers and testers, they are not following that, they are not bringing those improvements into practice, then that will end up affecting the project as well, because it means that then the developers and testers, they haven't learned anything from the reviews and there is no use of those reviews. The third one is there may be an improper attitude toward or expectations of testing. For example, not appreciating the value of finding defects during testing. Okay, so we did cover that earlier, that when a tester is bringing the bad information, bad news, like there are lots of defects, then maybe that's not taken in a good way, and maybe the tester wouldn't be appreciated, and instead might be blamed of due to finding the defects in the system. So these kind of issues do exist and they fall under political issues. Then the next one is technical issues. So the first one is requirements may not be defined well enough. So if requirements are not defined well, then of course that would be the basis of that project, and then it will result into a project being completed, but not what actually was wanted. The second is the requirements may not be met given existing constraints. Okay, so there can be different constraints and due to which the requirements may not be met. And now the constraints can be anything. It can be any kind of tool. It can be the data. It can be any kind of architecture, which is due to which the requirements might not be met. The third one is the test environment may not be ready on time. So if we need a test environment for testing, obviously, then of course that needs to be ready before the testing can begin. Otherwise, ultimately, it will impact the timeline of the project. The next one is data conversion, migration planning, and their tool support may be late. Okay, so if we need any test data for our testing, or if the data needs to be migrated from one environment to another, or if there is any kind of tool which you may need for testing and you need some support for that, if it's not there on time, then that will relate to a technical issue. The next one is weaknesses in the development process may impact the consistency or quality of project work products such as design, code, configuration, test data, and test cases. Okay, so now over here, like all these, they play quite a big role in testing of a project. And if there is any kind of process which is not being managed properly, then that will impact the project ultimately, and that will be one of the technical issue. So for example, if you are using a spreadsheet for test cases, and then one of the other person in your team is using something else for writing test cases, so means like there is no consistency because there is no process for that. And in the same way, when you are reporting any kind of bug, if there is no process for that and everyone is doing their own thing, their own process, then of course that will show that there are weaknesses in the development process. The last one is poor defect management, and similar problems may result in accumulated defects and other technical debt. Okay, so we will cover defect management later on today, but this point says that poor defect management may result in accumulated defects. So defects, when we manage the defects, there need to be a process which is identified and which is agreed with all the people who are part of that project or part of that organization, because otherwise we will not see any use of capturing the metrics of defects, and it will actually result into technical debt. So technical debt would be that maybe there would be a lot of duplicate defects, maybe some defects which were supposed to be resolved, but they are not. And then maybe there are lots of defects which are there, someone has logged them, but they're due to lack of any kind of management process on defects, they will never be resolved. So these are all technical issues. The next one is supplier issues. So a third party may fail to deliver a necessary product or service or go bankrupt. Okay, so this would be an instance where you are working on a project, and there might be a component, which a plugin, which you are using from a supplier, and they are not able to deliver you that service on time, which means that you have done your work, but because of that third party supplier, your project ultimately will be impacted really badly. The next one is contractual issues may cause problems to the project. The same would be that if you are working with any other company and there are any kind of contracts which usually are exchanged earlier before working, if there is any issue in that contract which is affecting the project, then that would be a supplier issue as well. So for example, let's say that there is a company who is, you are relying on resolving an issue which is of high priority for you, but according to the contract, it says that the company who will be resolving this issue for you, they can't do it before 3 days. So it was there in the contract, but it's a high priority one for you. So you want it to be resolved as soon as possible. So this will fall into the contractual issue, because of course in this case it is affecting your project, but you can't say anything to the supplier because that was part of your contract. Okay, so with that we are done with product and project risk. If there is any question, please let me know. Use the Q&A window for asking any kind of question in this session. So the next one is risk-based testing and product quality. Okay, so we have used this term risk-based testing, and we have referred to it many times, where we have mentioned that yes, risk-based testing, it needs to be used. Okay, so a risk-based approach to testing provides proactive opportunities to reduce the levels of product risk. So once we have the product risk, of course, we need to find a way to mitigate that risk. And one way is that we use risk-based approach to testing, which means that we have the everything as we have got the level of risk for, let's say, 10 items which we have to be which we have to test, and then based on the risk-based approach, we identify what needs to be tested first. And in that way, then it can reduce the level of the product risk. So we can go up with the high risk one first and keep the low one in the end, because it might be budget constraint, or it might be lack of time. So a risk-based approach to testing will help us. The second is it involves product risk analysis, which includes the identification of product risk and the assessment of each risk likelihood and impact. So this is referring to the same activity which we discussed earlier, where we have impact and probability, and then we have the product of those two, and then we identify that what would be the product risk. So we are analyzing the product risk, we are analyzing the level of that risk. The third one is the resulting product risk information is used to guide test planning, the specification, preparation, and execution of test cases, and test monitoring and control. So once we have the product risk for whatever we need for testing, then we can use that to write our test plan, because that will help us to write our test plan, because in that we can specify that what kind of risks were identified, and in our testing what we will be doing to mitigate that, how we'll be preparing ourselves for a risk-based approach, risk-based testing, how we'll be executing the test, what will be the order of tests, etc. And that will be helping us. The last one is analyzing product risk early contributes to the success of a project. So yes, that's absolutely correct. If we are identifying the product risk as soon as possible, as early in the product life cycle, then of course it will contribute to the success of a project. In a risk-based approach, the results of product risk analysis, so we know now what is the product risk analysis. They are used to determine the test techniques to be employed. So if we know what are the risks, then we can identify, we can agree on that what kind of test techniques we should be using, determine the particular levels and types of testing to be performed. For example, security testing, accessibility testing. So for example, if there is any project where a product risk has been identified in terms of security, then of course we will focus more on security testing for that specific project. Then the next one is determine the extent of testing to be carried out. Okay. Again, if there is a specific portion or a specific module which is of high risk, and when we analyze the risk, its impact and probability both are high, then of course that would be the major part where our testing needs to be focused. So that's why the risk-based approach will analyze that the extent of testing we need to perform. Then it comes prioritize testing in an attempt to find the critical defects as early as possible. So if we are going ahead with the risk-based approach, then it will be likely that we come up with the critical defects first, and so that can be fixed early, and that will give us confidence in the stability of our project. Determine whether any activities in addition to testing could be employed to reduce risk. For example, providing training to inexperienced designers. So this is like one example. So let's say that anything in terms of skills or training, if by giving training or by allocating experienced people, experienced resources to a specific project, if that can reduce the risk, then of course that can be done as well. So that can be one thing which the risk-based approach will help us to analyze in terms of product risk. Right, so to ensure that the likelihood of a product failure is minimized, risk management activities provide a disciplined approach to analyze, determine which risks are important to deal with, implement actions to mitigate those risks, and make contingency plans to deal with the risk should they become actual events. So when we are talking about the risk, the purpose of the entire activity is to ensure that we are minimizing the likelihood that a product will fail. And that's why if we whatever the risk management activities we have, they are there to make sure that these things are taken care of. That if, let's say, if there's an issue, then of course we know that what's the likelihood, but we also should be having a contingency plan that, okay, in a case that this scenario happens or this event happens, then what are we doing next? Because it might be that an incident happens, but there is no incident reporting system. There is no process, and no one knows that now how to handle, and everyone can be panicked, and that will actually not help the situation. It will just add more delays in order to reduce or the impact. So these are the, I think this is all for the risk-based testing and product quality. If there is any question, please let me know. The next one, the last section for today, is defect management. Okay, so now defect management, this is also, of course, quite important part of testing. So one of the main objectives of testing is to find defects. And once defects are found, then they need to be logged. And the way it will be logged, how it will be managed, it will vary, and it depends on the test levels that defects will be found at each test level. So it depends that on which test level the defect was found and what kind of SDLC model was being followed. So in order to manage all defects, there should be a defect management system. There should be a process to manage the defects with some rules, with some workflow in place. And defects may be reported in different stages, for example, during reviews, during coding, during static analysis, maybe for some documentation, or maybe during dynamic testing. So first of all, let's see what are the objectives of a defect report. So we always come up with a defect report. So let's see what are the objectives. So the first one is inform the team regarding any adverse event that occurred with details. So we need to, this is the first objective. The purpose of having a defect report is that if there is any event, any adverse event, then we are informing the team, we are informing the developers, the project managers, the stakeholders. So this is a way to communicate it to them that something which was not expected has happened. The next one is provide test managers a means of tracking the quality of the work product and the impact on the testing. So you remember when we did the metrics, then this is a key metric during test execution. So that's why test managers, they track the quality using this metric, that how many defects were there and what were the severity of those bugs as well. Provide ideas for development and test process improvement. So when we are coming up with defects and we are reporting the defects, it says a lot about the process which we are using right now in terms of development and testing. And a defect report helps us to improve those processes during time, because there is not a specific formula to come up with a defect report. Every organization, they are doing it in a different way, and maybe with time they realize that, okay, now this is not working, maybe we should add this, maybe this is not needed, we should exclude this. So which means that with the time they are improving that process. So these are the main objectives of a defect report. Okay, so now a defect report which is filed during dynamic testing, it typically includes these things. So we are talking about only dynamic testing over here. So remember that defects can be found and logged in different stages, in different phases. And let's say that if there is a defect in documentation, then maybe there may be a different process to log that kind of issue. Maybe the same issue, the same thing applies to them as well, maybe few of them. Maybe you're using the same defect management system for logging those kind of bugs as well. But right now we are only going through the ones which we the defect report which we file when we are going through the dynamic testing, which means like the test execution phase. Okay, so usually there is an identifier, there is a title and a short summary of the defect reported. Then there is the defect of the report, that when date of the defect report, that when the defect was reported, and who actually reported that defect as well. Then the next one is identification of the test item, that like what project you are testing and in which environment you are testing. It can be the test environment, it can be UAT, it can be production. So this needs to be mentioned. The development life cycle phases in which the defect was observed. Okay, so in which phase this defect was observed? Was it observed during design phase, the test design phase, maybe during coding or during test execution? So then the next one is a description of the defect to enable reproduction and resolution, including logs, database dumps, screenshots, or recordings if found during test execution. Okay, so once a tester finds a bug and that bug is logged, it should have all these basic information. And based on that, let's say if a developer is going to be fixing that bug, then the developer should be able to understand the details of that bug. The developer should be able to reproduce that bug. So that's why it's very important. This part is very, very important, because a description should be there, and that should be easy enough, simple enough, and clear, so that that can be reproduced. And if there are any supporting screenshots or videos, that makes it even easier. Then also, what are the expected and actual results? And most of the time, these expected and actual results, they are also given, they're also mentioned in the description area. Scope or degree of impact. Okay, so we already know that whenever we analyze anything which is not good, something which happens which shouldn't be, in this case of course a defect, then we analyze its risk. And the dimensions which we covered were impact and probability. So over here, usually when we report the bugs, the term impact is known as the severity. So that's the term we use usually for the impact of the defect on the interest of stakeholders. The next is urgency, priority to fix. Okay, so this is like how urgent it is to be fixed. What's the priority of that defect? Then the next one is state of the defect report. For example, open, deferred, duplicate, waiting to be fixed, awaiting confirmation testing, reopen, closed. Okay, so now there is a bug life cycle which we will go through in some time. And each company, they have their own format, they have their own life cycle. So there is no set rule for that. Yes, few things are very, very obvious, like they will be open, close, fixed. But some of them it's entirely up to that organization or that project, that how they have agreed what life cycle of a defect they want to be implemented, what works for their project and their team structure as well, the way they are working. So it will vary, and that's why we said that there should be a defect management process. Then next is conclusions, recommendations, and approvals. So if there are any kind of recommendations, then that can be mentioned in the defect report as well. It can be part of the description, or there can be a specific field for that. Global issues such as other areas that may be affected by a change resulting from the defect. Okay, so this is quite important, because maybe when you are logging a defect, then it may be due to a change. So if there is something which you know that what actually resulted into that defect, then you can give the reference to that change. Or maybe if something else can be impacted by this, then you can also give a link to that. Change history, such as the sequence of actions taken by project team members with respect to the defect to isolate, repair, and confirm it as fixed. Okay, so this is the history to keep a track of all the changes which happened to a defect from since it was opened till it's closed, so that later on, if someone wants to see that when this bug was fixed, or who fixed this bug, who moved it to the closed state, etc., then we have all this information in change history. And the last one is references, including the test case that revealed the problem. So if we have to link it to anything like a test case or the requirement, we can link it to that. We can add that reference. So remember, we said that traceability throughout the project is very important. So over here, if we are linking our bug to a test case, so basically we are tracing it back to the test case, and then the test case will be linked back to the requirement as well. So this is typically few fields which are used. They can be more as well. It can be in any way a company can use, that can be totally different, but these are the main fields which are used. So the ones you would have noticed that few of them I have highlighted in blue. These are the ones which if you're not using a spreadsheet for reporting defects, and if you're using a defect management system, then these fields which I have highlighted as blue, these are auto-populated. These are automatically populated. Like if you are creating a new bug, then identifier will already be there. You don't need to specify an identifier. Of course, if you are not using a tool, then if you're using a spreadsheet, then you need to come up with a way, and an identifier needs to be there. Like for example, if there is a project, and then you can say, okay, it will, all the defects will be referred as proj as a project, and then 1, then proj 2, then proj 3. So in that way, you need to come up with an identifier system. But otherwise, if you are using a tool, then it will uniquely identify, put identifier automatically. The same is with the date as well. So you don't need to specify date. If there is a tool, then whenever you are reporting a bug, it will come up with the date itself, and it will also manage the history as well. So whenever the status is changed, whenever the assignee is changed, or there are any changes done to the bug, it will be maintained in the change history in that tool. Okay, so now this is there are different tools which are being used, and of course some of you might be already using any defect tool, defect management tool. So I just wanted to show you a glimpse of this bug report, a simple bug report in Jira. So because what we have read over here, I thought that it would be easier to see that as well. So this is, I've just taken a screenshot just to show you that in Jira usually how a bug looks like. So we have a project name, We have an identifier, as I mentioned, that we don't have to specify identifier, it's automatically given. Then we have a text field where we can give the title and summary of the bug. We can also have some attachments. These attachments can be the screenshots. These can be video as well. We can give the link to the requirements. We can give links to the test cases. So I didn't wrote test cases over here because this is from Jira. So Jira is a defect management system, and we can't store test cases in Jira. It's not a test case management system, but there are few tools for test case management system which which links to Jira. So in that case, then using those plugins, you can link them to Jira, and then you can also link any bug to the test case as well. Then there can be description, and in description, you can give all the details, the steps, how to reproduce, and also you can also specify environment over here. Otherwise, there can be a specific, you can also add different fields, just like these description field. You can also add more fields as well. So you can have an environment field, you can have a priority field, severity field, and then in description, you can have all the details with the expected and actual result. Then over here, we have a field for comments. And then over here, it keeps a track of all the changes. Then coming here, it will be like what's the status of the bug right now. Then the author that who reported this bug. Right now, I logged in as my user, so that's why it's showing mytestingorbit over here. And this is also automatically done. So whoever is creating the bug, they don't have to specify the reporter. It will be automatically captured via their login. And the same is with date as well. So of course, at the time I captured, it just showed me that it was created 6 minutes ago and when it was last updated. But after like a day or so, it will show you the date that it was created. Like let's say 1 day ago, what was the date and when was the last time it was updated. So it will keep a track of everything, and all the updates will also be captured in the history section as well. So there are some other things which, of course, right now we are not talking about, like what are the labels, what's the sprint, and what is the story point estimate. But I just wanted to show you a graphical representation of how a bug report usually looks like. And those of you who will be continuing the live project, the live testing project with me, we will be using Jira. So I will be showing you lots of things in Jira as well. So I think that will make things clear as well. Okay, so it's a usual bug or defect life cycle. As I said, that there can be a lot of variations into it, but I just took one example just for the sake of explaining to you. So this is a life cycle of a defect. So let's say that a new defect was raised, and when the defect was raised, it came up that it's not a valid defect, so it will straight away will be rejected. If it's valid, then it will go to the open state. Then over there are two options. One, it will be fixed, or maybe let's say if it's not of a high priority right now, or maybe it's we don't want to fix it right away, we can mark it as deferred as well. That this means that this will not go into the queue of the developer, and because we have agreed that this bug, okay, we want to keep this bug, but we don't want to fix this bug right now. If we agree to fix that bug, then it will be fixed and then it will be retested. And now when we retest that bug, one possibility is that it will be closed. And the other possibility is that when we are retesting, again, it's not working. In that case, then we have to reopen that bug. And then once it reopened, then the same cycle goes on, that it's fixed, it's retested. If it's fixed, it's closed. If it's not fixed, then again, it will be reopened until it is closed. So this is a quite generic defect life cycle. This was not part, this exactly life cycle is not part of the syllabus, but I have seen few questions which does come up. So that's why I just wanted you to show the graphical representation so that you are sure about that, how the bug life cycle works. Okay, so the same standard which we did earlier as well, 291193, this adds this includes the test plan details, this includes the test cases, like a template as well of the test report, and this also includes an examples of the contents of a defect report. And just, I've also mentioned it over here that the defect reports are also known as the incident report. So if you hear the term incident, the same as the defect report. So now if there are, this is the end of the session today. If there are any questions, then do let me know. Otherwise, we can continue with our uh, practice questions. Okay, so there are no questions. So I think let's move on to the practice question then. The first one is, a new system is about to be developed. Which of the following functions has the highest level of risk? So please go through the options and let me know what you think is the correct answer. Okay, I have got an answer. Let's just wait for a couple of more and then we can go through the question. Okay, I have got three answers and actually four of them. And all of you have given the answer A, the option A, which is actually the right one. So, okay, so all of you have given me the option A as an answer, and this is the correct answer. So let's go through it. So over here, the A option is likelihood of failure 20%, impact value 100,000. Okay, so just in case those of you who doesn't know that how to calculate, earlier we said that the likelihood of failure multiply by impact value gives us the level of that risk. And so in this case, if we say 20%, 20% would be 0.2, and then we multiply it with 100,000, and that will give us the 20,000, which is the highest one. If we calculate the other ones, B, option B would be 15,000, C would be 5,000, and D would be 4,000. So that's really good that all of you got your answers correct. But I just wanted to explain for those who might not understand that how we actually calculated it. All right, that's good. The second one is, which of the following statements about risks is most accurate? Okay, I've got an answer from Vineet. Let's just wait for a couple of more answers. Okay, I've got an answer from Madhuri as well. Okay, so I have got now few answers. So Vineet, you have answered twice on that, or that was the earlier one? Maybe I've, okay, no. Okay, so I've got your answer now as well. Okay, and then I've got an answer from Shalini as well. All right, let's see that which is the correct option. I have right now the options which I have got uh, from all of you are C and D, and I would say that the C would be the correct option. And let's see how. So I already mentioned that it's difficult to differentiate between project and product risk, but anything that impacts the quality of the system which we are delivering, it's most likely to lead to the delay or the increased cost. And anything which cause delay to the project, it will affect eventually the quality of the delivered system. And when we spoke about the risk-based approach, the risk-based approach manages product risk throughout the testing, through testing. So that's why it impacts most directly on the product risk. Hence, C is the correct option. So if you go back to the slides, wherever we spoke about risk-based approach, we mentioned product risk. Let me go back to that slide so that it's clear. Okay, see over here. In a risk-based approach, the results of product risk. So whenever we talk about risk-based approach, we associate it with product risk because that approach, it manages the product risk through testing. So that's why directly, if we talk about direct impact, then it will be on product risk rather than project risk. So that would be the most appropriate option. Okay, let's go back to our question. So I hope that this one is clear to the ones who gave the option D. If there is any confusion, please let me know. Okay, we can move to our next question. This is, who determines the severity of the defect? A developer, a customer, a tester, or all stakeholders? Sorry, there is a typo. There's no D at the end. Okay, I've got an answer from UV and one from Shalini as well. Okay, let's see. Right, so so Shalini and Yuvi, both of your answers are correct. So I've got an answer, another one as D, which is incorrect. Okay, so let's see. So tester is the correct option because severity is impact of of defect on an application, what we are testing. So the tester determines the severity after the defect is detected. So the tester is the one who report the defect, and that's why a tester can identify that what was the severity of that defect. Yes, when we talk about the priority, that's a totally different story. So the priority would be identified by maybe a stakeholder, maybe the project manager, whoever is representing the business will identify the priority because they have to make sure, they have to identify that how urgent it is to be fixed. So the priority is different, but when it comes to severity, tester is the one who identify, who determine the severity of the defect. Okay, so with this, we have come to end to our today's session. So next session will be our last session, and with that, then we will complete our ISTQB syllabus. So only one. So we have ended module 5, and the last module, which is the tools, that will be covered in last session, which will be on Thursday. In today's session, if there is any question, please feel free to ask. Okay, I haven't got any question, so that's fine. Later on, if you come up with any question, please let me know. You can ask in the group, you can message me, and I'll try my best to come back to you as soon as possible. As usual, I will upload this to the playlist on YouTube. I will also add the slides in the file section of the group, and I will also upload the questions as well, the assignment for this session. So I'll speak to you on Thursday. Till then, take care of yourself, and I'll see you in 2 days. Take care. Bye.